I didn't say that much, did I? All right. Nothing. Never mind. Go back to sleep. Suppose a card is drawn from a well-shuffled standard deck. Okay, we need to get to know a card deck because they like to use this example a lot. How many cards are in a deck? Does anybody know? 52 without the jokers. I don't think they ever use the jokers. How many suits are there?
4.
Yeah, spades. There's 2 black suits, right? Spades and clubs, and then there's 2 red suits, hearts and diamonds. Did you guys know this already?
No.
Are your family card game players?
No. We weren't
Oh, just a gambler.
Yeah.
Professional.
Sam's got a problem.
Mr. Landers taught us how to play it.
I can quit
Did he?
anything I want.
No, and then he got in trouble by Mr. Then he got in trouble by Mr.
Down.
Mr.
A
Landers
lot of
taught us
money
how
needs to
to
be
Yeah.
back up.
This is a long time ago, but like this is back when. You guys had Mrs. White, right?
Yeah.
The
Science teacher?
the science, yeah.
Mm-hmm.
Like back when she was in school, so it was a long time ago. Like her husband was, and some other people were in my study hall, and a lot of times they didn't have anything to do, so they'd play poker, like with chips and stuff. And I remember one time there's like, some like our principal at the time was giving a tour to somebody walking by. It's like, put the cards on the table. Just got that recorded. The images. Okay. Anyways, so how many cards? There's 4 suits. How many cards are in each suit? 13. So there's 13 hearts, 13 diamonds. So anyway, and since half of them are red, half of them are black, so there's like 26 red, 26 black. How about face cards? Do you guys know how many face cards are in
There's 3 per
Right. 3 per hearts, 3 per diamonds. There's Jack, Queen, King. They all have faces on them. So there's like 3 times 4. There's 12 altogether. Anyway, if you forget or whatever, I'll remind you. Okay.
You have to reduce these.
Yes, reduce as completely as you can. A black card. So what are the odds on 1A of drawing a black card?
26.
Okay, we're going to do fractions.
26. 1/2.
Right, half of the cards are black cards, so there's a 1 in 2 chance. Okay, you could say there's 26 out of 52, right? But that reduces to 1 and 2. Okay, what are the odds of drawing a spade?
1/4.
13 out of 52, but that's just 1 in 4. Because there's 4 suits, the spade is just one of the suits. Does this make sense, Allison? You said you didn't play cards. Do you know what I mean by suit?
No.
Okay. Maybe I'll just go grab the cards later, but I don't know
You
if I
can
want to.
draw one on the board.
How
Draw 52.
about let's just go to 4 and then play poker for the rest of the day.
I think that's fair.
Yeah, we're basically learning how to play blackjack in Vegas
Yeah.
here. What are the odds of getting not a spade?
3 out of 4.
Right. So, how are these? This is kind of an important point that we'll need for this chapter. How are these 2 related? Okay.
The opposites.
Yeah, if they're opposites, what should always be true about opposites on probabilities?
Add up to the total.
They should add up to 1. Because you can either draw a spade or a not spade, but it's got to be one of them. So when you add these together, they should add up to 1. Like there's 100% 1 equals 100%. There's 100% probability you'll draw not a spade or a spade. Does that make sense? Like what's the probability I'll pick a student at random and it's a guy? 5 and 9. What's the probability I'll pick a student at random and be a girl? 4 and 9. Because those are the only 2 possibilities. Together they should add up to 9 out of 9 or 100% chance. That'll do one or the other. So when there's opposites, they should add up to 1. If that's like the only possible thing to happen. Okay, anyway. maybe they'll make sense more later on. Okay, 3 is kind of silly. What's the probability you'll draw a red diamond? Well, how many diamonds are red? All of them. So what's the probability of drawing a diamond? 1 in 4.
Well,
Okay, we're doing this later. It's not what's the probability of getting a red card if it's a diamond. That would be 100% chance. But that's not what they asked. They said, what's the probability of drawing a red diamond out of the entire deck? What's the probability of drawing a black diamond? So what's that going to see? Yeah, 0. There are no black diamonds. What's the probability of drawing not a black diamond? Yeah, 1 out of 1, or like 100% chance. It's 1. Because it's impossible to draw a black diamond, you're guaranteed to not draw a black diamond. Mr. and Miss Smith each bought 10 raffle tickets. Each of their 3 children bought 4 tickets. If 4,280 tickets were sold in all, what is the probability that the grand prize winner is Mr. or Mrs. Smith?
Would that be 10 out of 4,280?
Close. Okay, so together, how many tickets did Mr. and Mrs. Smith buy?
20.
20. They each got 10. So together they got 20. So that's like the target. And what's the total? The target out of the total, 4,200. Does that simplify?
Yeah.
Of course it does. So if we divide by 20, those cancel out. Divide by 2, that's 214. So it's 1 and 214. You guys know how to simplify these on your calculator? Plug it in fraction and hit equal. Okay, what's the probability that one of the 5 Smiths is going to win the raffle?
Would it be,
So the parents have 20 tickets, and each of the 3 children have 4. So how many do the children have? 12. 3 times 4. So we got 20 and 12. So the family bought 32 tickets. Let's not put that over there. 32 tickets out of 4,280 tickets. Not great odds. This is why I like percents the best, because it's kind of hard to visualize this. That would be less than a 1% chance. So it'd probably be like a 0.9% chance, roughly. So, which is less than 1%, less than 1 in 100 chance. C. Oh no. Yes. What's the probability that none of the Smiths won the raffle? Okay, well, if 4 out of 535 would give the Smiths the win, how much would not give the Smiths the win?
531.
Alright, you guys see how I got that? If 4 of the chances out of 535 are for the win, and the rest of the chances would be not to win. So he just did 535 minus 4. So they're probably not going to win. If you understand the probabilities, I feel like it makes you less likely to be a gambler.
or you're just so confident that you think you can win.
That would just make you a fool. Because that's not how probabilities work. I think it was kind of like the games are designed to take your money, right? Not give you money. So it's kind of like an investment that you're almost guaranteed to lose. Anyways, number 7, New York City is divided into 5 boroughs. Manhattan, this is educational here. Manhattan, Queens, Bronx, Brooklyn, Staten Island. Suppose that a New York City telephone number is randomly chosen. Explain why the probability that it is a Manhattan telephone number is not 1 in 5. If we choose a New York telephone number at random, why is the probability that it's from Manhattan not 1 in 5?
Well, I guess a higher population than the others.
Yeah.
Yeah.
So you gotta say that's amount. I'm gonna say populations in each borough vary. Let's see how the book said it. There are not equal number of phone numbers in each borough. I give mine the prize. What do you need to know in order to find the correct probability?
Population.
Yeah. Well, not exactly the population. A little more specific.
How many phone numbers?
Yeah, because that kind of varies too, right? And this was written back in the day of home phones. So you might have like, well, actually that would just be one phone number. Well, some people have a home phone still, probably. Do you guys have a home phone?
My grandparents.
You do?
How old is this book?
I don't know, like, I'd guess like 30. You look at the copyright at the beginning. What'd you say?
Some people need home phones because they're self-servicing.
You guys don't? Interesting. Oh, Copan, you've been forgotten. I'm not gonna look it up. I can find it. All right. Oh yeah. So what we would need to know is obviously the number of phone, and also there's work phone numbers and stuff
Oh, another
in each borough. Yeah, actually the book's answer name is better than mine. Because they said phone numbers, not people. All right. So, for this next part on number 9, we need to turn back to. We need to turn back to page 601. And that little table. Have you guys ever played Settlers of Catan?
Yep.
Of course Sam has.
It's a fun game.
one.
I
I
recommend.
tried to play it.
I recommend.
601.
What, you didn't like it?
No.
You like any board games?
Depends.
You're fired. Okay.
Card games.
Anyway, I always kind of think of this when I'm playing that game, which is like once a year. That's our Thanksgiving tradition. So when you roll 2 die, that table represents all the possibilities. You could roll a 1-1, you could roll a 1-2, 1-3, 1-4, or you could roll a 2-1, 2-2, 2-3. So how many possible rolls are there when you roll 2 dice?
36.
Yeah, 6 times 6, basically. Oh man, shoot. Maybe we need to go back and do the counting. lessons after. We'll do it after this. Yeah, there's 36 possibilities when you roll 2 dice. Because you have 6 possibilities on the first die, 6 possibilities on the second die. Kind of combine those, that makes 36. You multiply. If you look at the table, it kind of shows all 36 possibilities. A 1, 1, 1, 2, all the way up to a 6, 6. Okay, so they're going to ask, let me just give a quick example. What's the probability that you would roll a 3? Now, in that group, in that table, how many spots, how many combos could give you a 3?
11? Oh wait,
No.
it's 3.
Okay, not roll a 3 on one of the die, but roll a 3 in total. What's the or how many ways could you roll a 3 in total? 2. If you look at the table, it's the 1, 2, and the 2, 1. So the probability that you roll a 3 is 2 out of how many possible rolls? 36, which reduces to 1 in 18. The probability of rolling a 3 is 1 in 18. Okay, if you get a little higher, your probability gets a little bit better. Because what's the probability of rolling a 4? Okay, you kind of have to look at it as a diagonal, because you guys see where the 4s are? It's a 3, 1, a 2, 2, and a 1, 3.
Yeah.
If you look, they highlighted, the red highlight is rolling a 9, the blue highlight is rolling a 10. So rolling a 4, there's 3 ways you could do it. 3, 1, a 2, 2, or a 1, 3. So it's 3 in 36, which is a 1 in 12 chance. You guys know what the highest probability is? I mean, what's the highest chance to roll?
Isn't it 6 or 9?
It's a 7. Basically, because no matter what you roll on the first die, you can still roll a 7 with the second die. That's kind of why. That's kind of how it works. But to roll a 2, your first die has to be a 1, and your second die has to be a 1. So it's harder to do that. Anyways, yeah, 7's the most likely roll. Okay, so let's go back to number 9. It says, what is the probability of rolling a 6?
1 over 6?
No. How many ways can a 6 be rolled?
5.
Yeah, if you look, I don't know how to point it out, but there's a 5, 1, 4, 2, 3, 3, 2, 4, 1, 5 diagonal.
Yeah.
Those 5 rolls give you a 6. So there's a 5 in 36 chance of rolling a 6, which does not reduce. So we're just going to leave it like that. Okay, B, what's the probability of rolling a 7? I said this was the most likely roll. Yeah, if you look at that middle diagonal, the longest diagonal, it's 6, 1, 5, 2, 4, 3, 3, 4, 2, 4, 2, 5, 1, 6. There's 7 of those, or sorry, 6 of those. So there's a 6 in 36 chance, which reduces to a 1 in 6 chance. Sum of 8.
5.
Yeah, 5 again. So the chances of rolling an 8 are the same as the chances of rolling a 6.
That's a good sign.
Do you? Is that what you feel?
I feel that too.
You know what I feel? Complete lack of empathy. I got a problem. I lack human emotion. Okay, the 2 dice show different numbers. So what's the probability that the 2 dice are different numbers?
Would that be 30 or 36?
Okay, you could use that table to figure it out, but okay, I think they want us to use the table. So let's talk about it from the table's perspective. Here's the easier way to do it. How many doubles are there? How many possible double rolls are there? 6. So how many not double rolls must there be? 30. So the probability of not rolling doubles is 30 out of 36. Because there's 6 doubles, there must be 30 non-doubles. And if you divide those by 6, it's a 5 in 6 chance. The way I was thinking about it is, no matter what your first die roll is, like 1, 2, 3, 4, whatever, doesn't matter. What's the probability that your second die roll would match that? Oh wait, did they want the probability of rolling doubles or not rolling doubles? Did I do that right? Different, okay, so we did it right. What's the probability of matching that 3? Well, there's only 1 3 on the second die, so it's just a 1 in 6 chance. So that means there's a 5 in 6 chance. We're good. Okay, anyways. Just getting your gambling itch up.
What?
Making you want to play cards.
Just
What's shell shockers?
This one was like tape.
It's Leo's favorite game.
I bought a mouse today, so I'm about to go off.
Really? You actually